In this video, we're going to solve a problem which appear in JEE Advanced 2015. In this particular problem, we have an equation in a trigonometric equation, and we need to find the number of solution in this interval 0 to pi, 0 to 2 pi, sorry. So that's the problem. So let's go ahead and solve this problem. First, we consider the given equation. Notice that in this given equation, we have cos to the power 4x and sine to the power 4x term, as well as we have cos 6 term and sine 6 term. Now, to get a solution, we have to rewrite all the equation, right, in a same form, right? Either 2x form or cos x form, something. Then only we are able to solve this particular problem. So that's why first we consider the terms separately and then try to simplify them, and then we'll proceed. So first we consider, right, that cos 4 and sine 4 term, right? So cos 4x and sine 4x. So this particular term we consider. Now, here we notice that, right, this term can be easily simplified using the formula, right, that a square plus b square, because cos 4 and sine 4 can be written as cos square x whole square and sine square x whole square. And we also know that, right, that a square plus b square is equal to a plus b whole square minus 2ab. So therefore, the required expression can be written as cos square x plus sine square x whole square minus 2 sine square x and cos square x. We know that for any values of x, the cos square x plus sine square x is equal to 1, and that 2 cos square x and sine square x can be easily written as 1 by 2 multiplied by 2 sine x cos x whole square. Why we wrote it? Because we know that 2 sine x cos x is equal to sine 2x. So therefore, the given expression or the middle two terms, right, cos 4 plus sine 4x is equal to 1 minus sine square 2x. So we are able to simplify in the form of that cos 4 and sine 4 in the form of sine 2x term, right? It's a function of sine 2x. That's we are going to obtain it. Now our next job is to go ahead and simplify the other two terms, that is cos 6 and sine 6 term. Let's go ahead. We consider the other two terms, cos 6 and sine 6x, and this two term can be written as cos square x whole cube plus sine square x whole cube. Here we recall the formula, what is a cube plus b cube. In the factorizing form, it is equal to a plus b into a square plus b square minus ab. So here, to simplify that cos 6 and sine 6x, we consider a is cos square x, b is sine square x, and hence it will be written as cos square x plus sine square x into cos 4 plus sine 4 minus cos square sine square x. Now also here we can easily simplify that using that other formula. So therefore, here also we can notice that a square plus b square is equal to a square plus b square minus 2ab. So therefore, cos 4 plus sine 4x can be easily written as cos square x plus sine square x whole square minus 2 cos square and sine square x. So therefore, here we can use the basic identity that cos square and sine square x is equal to 1, and hence it will be equal to 1 minus 3 sine square x and cos square x. So as we did already, right, that 3 cos square x sine square x now can be replaced by 3 by 4 into 2 sine x cos x whole square. If we recall the identity of sine 2x, it can be written as 1 minus 3 by 4 sine square 2x. So therefore, the last two terms, cos 4x sine 4x, this one, and cos 6 plus sine 6, both are rewritten as in the form of sine 2x. And also, cos square 2x can easily be written as 1 minus sine square 2x. Let's go ahead. Now, cos square 2x also can be written as 1 minus sine square 2x, the first term. So therefore, the given equation can be reduced to as in the form of sine 2x. So we can do some basic arithmetic calculation, and if we do, we can easily understand that it will be reduced to 5 by 4 minus 10 by 4 sine square 2x, and hence sine square 2x is equal to 1 by 2 and sine 2x is plus minus 1 by root 2. So therefore we get sine 2x is equal to a well-known value, and that plus minus 1 by root 2 is a known angle. So therefore, we can proceed to the general solution step, because we know that that 1 by plus minus root 2 will be sine pi by 4, right? That we all know. So first we consider that sine 2x is equal to 1 by root 2. Take the positive sign. And hence we can say sine 2x is equal to sine pi by 4. And thus, if we recall, right, that 2x is equal to n pi plus a minus 1 whole to the power n pi by 4. So therefore, x is equal to n pi by 2 plus minus 1 whole to the power n multiplied by pi by 8. Now we need to find out the solution inside the interval 0 to 2 pi. So here we cannot use the inequality because as we solved that one of the problem already you've seen in other videos. So here we don't consider that. Why? Because here we have the plus minus 1 whole to the power inside. So the calculation became a little difficult. So to solve this problem, we just go ahead and use the trial error, that is the substitution technique. So put n equal to 0, we get x equal to pi by 2, n equal to 1, we get 3 pi by 8. And notice that these values, right, if we go ahead, right, we get that these values are lies between, right, 0 to 2 pi. So only we can see that we get the solution, right, for n equal to 0 to 3, which lies between 0 to 2 pi. Hence, sine 2x is equal to 1 by root 2 imply that x is equal to pi by 8, 3 pi by 8, 9 pi by 8, and so on. Okay, that's it. So 4 values are possible when we take or consider the positive sign. Ahead and take the negative part of it. So sine 2x is equal to minus 1 by root 2. Hence, right, we know that sine of minus theta is equal to sine minus of sine theta. So therefore, sine 2x can be written as sine of minus pi by 4. 2x is equal to n pi minus 1 whole to the power n and pi by 4, and thus x we can calculate. Here also, we just substitute that in value. So n equal to 0, it will be minus pi by 8, which is less than 0. So we need to exclude that. N equal to 1, we get it as 5 pi by 8. N equal to 2, we get 7 pi by 8. N equal to 3, we get 13 pi by 8. So these values are actually less than 2 pi. And for n equal to 4, we get it as 15 pi by 8. So therefore, if I substitute n equal to 5, we get it as 21 by pi 8, which is obviously greater than 2 pi. So therefore, inside the interval 0 to 2 pi, the solutions we can take it. So n equal to 1 to 4, right? That's 4 values is possible. We can easily find out the general solution for both the cases. So when we take the positive sign, sine 2x is 1 by root 2, we get 4 solution. When we take sine 2x equal to minus 1 by root 2, we get 4 solution, and these solutions are distinct. So therefore, we say that, right, the number of solution of the given equation in the interval 0 to 2 pi is 8, and that's it. So therefore, 8 is the correct answer. Hope you understood the problem. Thank you.